Power valves are one of the least understood parts of the tuning process on a 4150 series carburetor. So today we're going to talk about it, what they are, how to tune them, and to break one down so we can take a look on the inside, see how they work. So a lot to cover today. Let's go. So the power valve is a vacuum-operated enrichment system that just gives more fuel to the carburetor when the vacuum gets to a certain point and allows the valve to open up. So the purpose behind a power valve is to improve that performance, the drivability, part throttle, cruising, even fuel economy can be improved by using the correct size power valve. And that's what we're going to talk about today, is how to tune this to get it to the best condition. Now, there's a lot of misconceptions about this power valve, that you're only going to touch this once and you're done with it. And that's not the case. It is part of the tuning process, and it goes a little bit bigger. So we're going to talk about all the little details here, but I just wanted to cover, what that thing is for and why it's so critical. But before you can even start to do this, you've got to get all those other things correct. Ignition timing is certainly hugely important when you're doing any carburetor tuning. Getting your fuel system set up right. We've talked about that 1,000 times on this channel. If you don't have the fuel system set up right, it doesn't matter what tuning you do in the carburetor, you're going to screw it up. The other big critical point here is getting the right size carburetor. Now, if you've done what a lot of guys do and just put too big of a carburetor on it, it is going to be very difficult to tune this because the CFM of the carburetor is fixed. You can't tune CFM. You can't change that size. So making sure that you've got the right size carburetor certainly can help out this process and get you down the road a little bit better. Now, generally, power valves are only on the primary side of the carburetor. Secondary is operated a little bit differently, but sometimes you can see a power valve on that secondary side. So let's talk about power valves and jetting and how they go hand in hand, because literally you're going to kind of tune these at the same time. Now, like I made mention of, folks will just take the measurement of engine vacuum and set this once and think they're done. You can't really do it that way, and I'm going to show you the tuning process here in just a moment. But when you talk about jetting, the reason why you can run a little bit smaller jet on the primary side of the carburetor is because of the power valve. It enriches and gives it fuel as the load increases, as the power demand is asked for out of the engine. And when that happens, the power valve is there to enrich the fuel system, give it more fuel. It's a unique feature to the Holley carburetor, and it's a brilliant design the way it works. But this is also the reason why folks get into a little bit of trouble where they say, well, Holley's just mindlessly dump fuel. They can if you don't have it tuned right. And most folks will go, well, I'll just jet it down a little bit and not even consider the power valve in the equation, where this becomes a big part of it. So the jetting goes in, and power valves go hand in hand. And like I said, you can typically run a smaller jet size on the primary side because you've got that power enrichment system. So when you talk about getting a little bit better fuel economy, I know that seems insulting with the Holley carburetor because everybody just thinks that they don't have that capability. You can tune them to get a little bit more economy. It's just a matter of getting these two systems working together. Now, when the power valve's installed, you've got two sides of it. You've got the wet side here where it draws it out of the bowl and it draws fuel into the jets, and this is where the fuel is drawn through to get into that enrichment circuit from the power valve. On this side, it's the vacuum side, so it reads the vacuum from the engine through a port right here, and what that does is when the vacuum in the engine changes, it's referenced on the power valve. When it gets to the rating of the power valve, that's when it will open. So when we talk about sizes on the power valves, I've got 4 different sizes here in power valve. This one is a 2.5. This one is a 4.5, 6.5, and 8.5. Now, when you look at them, they don't look any different, but when you look at the springs, you can see that they're a little bit different. But always go by the number on it. Don't look at the spring and gauge that as, which one is which. There's no way you could tell that. They're stamped on the bottom of it there on the vacuum side of it so you can read what it is. So let's talk a little bit about how to determine what vacuum size on the power valve that you want to start with. Not the final point in it, but where the starting point is when you're tuning this. Now I cut this power valve apart so you can kind of see how it all works and how the pieces go together. So what I did is I cut the end off here, separated the plunger and the valve portion and the spring, and it's very simple. There's not any complicated circuits within here. It's just a very, very simple mechanism that monitors the engine vacuum, and as that hits the diaphragm, it overcomes the spring and then it releases, and this allows the fuel to flow through the power valve. So when you look at these, again, there's not a bunch of little weird, circuits in here like there are on a metering block. It's just a very, very simple valve, vacuum operated valve. And those little ports right there is what flows the fuel into the power valve channel restrictors, and how much fuel it actually flows through the carburetor to get down into the engine based on the demands it needs. So I don't want you to look at these and think that there's some really complex, wild, crazy deal. They're fairly simple. They're not overcomplicated. They all operate the exact same way no matter what brand you buy off the shelf. So why don't you take a look at that so you can see how they're put together and see how they're made. So these are the standard power valves that you can buy. They come in the carburetors, but there's a couple other different ones too that I want to talk about. There is a high flow power valve that is typically used when you have a ability to change the channel restrictions within the power valve circuit. And we'll take a look at this a little bit closer in a moment, but there's little restrictors in there that you can open and close or make smaller or bigger depending on how much fuel you want to flow through there. And those high flow power valves are used in that situation where you've got the adjustability. You can flow more fuel, but if that channel restrictor says that's all that's going through there, it doesn't matter how much fuel. So don't think you can put a high flow power valve in a standard metering block. You're defeating the purpose. You're spending money on something that you don't use. You have to have that ability to change that restrictor. Now, most of the time when you're going to upgrade to that higher flow power valve, it's because you're in a higher horsepower situation. You just need a little bit more fuel. Generally on a street car, in today's world, I guess this could be a little bit different, but generally you're not going to have need for it unless you're, 7, 8, 900 horsepower, something like that, which in today's world isn't that uncommon. Now, the good thing is with the Holley carburetor, you can buy an adjustable metering block that has these different circuits in here. Air bleeds in the top of the carburetor can be made, and you can certainly drill these and add some channel restrictions to where that's adjustable, or you can purchase these blocks separately. So you can do a little bit of upgrading on an older style Holley, but those carburetors are out there and fairly reasonable. I mentioned the Edelbrock VRS, or had it on the counter here in just a minute ago. Those have a fully adjustable block with all the restrictors in it and emulsions and the air bleeds on top, so you can tune all those circuits, and having that power valve circuit is certainly a key one in it. Now, the next one we're going to talk about is what we're calling a dual stage power valve, and those were kind of unique in the fact that they had two different ratings, one for kind of light load and then one that was made for that wide open throttle performance. Kind of a little bit cool design. I think they were at a couple of different sizes that you could choose from on the light side and then on the wide open throttle side, but those were discontinued. Holley saw no advantage in those based on the regular power valve, and they were probably a lot more expensive to manufacture. I don't think they sold a lot of them, so it's probably one of the reasons why they're gone. But it was a nice theory, but in practice, you really don't need it. Now, we've done in the carburetor tuning videos in the past, you'll understand that it's imperative to have a vacuum gauge so you can monitor the manifold vacuum in the engine, and this is how you're going to make the reading here. So how do you determine what size power valve to start with in that 4150 series carburetor? It's easy. So the first thing you need to do is, again, make sure the fuel system and timing are all where they need to be. Warm up the engine completely, attach the vacuum gauge to the manifold side or the manifold port on the vacuum. Got to be careful there. Remember, there's timed and manifold vacuum on all those carburetors, so you got to make sure you get it in the right one. If you're a manual transmission, it's a little bit easier. You just need to be out of gear and at idle. Automatic's a little bit different. You'll need a friend to help you out. But automatic transmission, once it's fully warmed up, put it into gear and then have somebody hold on the brake sitting there at idle, and then you can read what the manifold reading is. Now, when you are in gear, whatever manifold reading that you got in park when you were adjusting the carburetor for the idle mixture screws, it's going to drop down a little bit. Same when you're driving, it's going to drop again because there's load on the engine now, and that's a good example of understanding how vacuum works in an engine is by reading it at different places. I know it's not the sexiest gauge to have in cabin in a vehicle, but having a vacuum gauge in there to read what the engine is actually seeing will help you make these adjustments as you go forward. AFR gauge is certainly one of the most incredible and consistently good tools that you can use to tune a carburetor. 100% of the time, I will always recommend you make that investment. Now, the good news is you can buy some fairly inexpensive ones. Make sure you get a wideband O2. The narrowband O2 doesn't give you enough information, I don't think, to properly make the assessment on whether you're too lean or too rich or when the power valve is opening especially. Get a good wideband O2 sensor and AFR gauge. Again, kind of expensive on some of them, and the ones that are really, really portable and easy to use are very expensive. But the more you tune, the more you realize you just need that. So let's use a couple of examples here. So the first one, let's say when you're in park, warmed up, in transmission and drive, automatic transmission, fully warmed up, and you get a reading of 13 on your vacuum gauge, you'll split that value in half, which is give you 6.5, which means you'll use the 6.5 power valve. Now let's say it's something a little bit different. Let's say that in gear, your vacuum reading is 8 inches of vacuum. Divide that by 2 gives you 4. Now, where do you go? Do you go to the 3.5 or do you go to the 4.5? And here's the rule of thumb here. 3.5, which I thought we had here, 3.5 is going to open it at a slower rate, okay? Think about that for just a second. The engine vacuum has to drop all the way down to 3.5 before the power valve opens and opens up fuel. And you want to always err on the side of giving it a little bit too much more fuel. So in this case, the 4.5 will open it an inch sooner. Does that make sense? If your engine's going to see 4.5 of vacuum sooner than it's going to see 3.5. So always err on the side of giving it a little bit more fuel. It's one of the reasons why Holleys get all the crap, I think, is because people will incorrectly size that power valve, and when you do that and it opens it up too soon and it dumps more fuel, certainly the engine can get into scenarios that like that, but this is why we're spending the time in it to get the base calibration on the power valve before we go any further. So always err on the side of a little bit richer. In that instance, the 4.5, because it will open sooner than the 3.5. So this is where the AFR becomes really, really important in the tuning process. So let's say you put that 4.5 power valve going and drive it around. It's okay, but maybe you've got a little bit hesitation that you want to get rid of. Most folks will make two really big mistakes here. They will say, well, I need to change the nozzle size on the accelerator pump, give it a quicker shot of fuel. Maybe that's going to cure it. It might. Or the most common mistake they'll make is, well, I just need to jet it up a little bit, give it a little bit more jet, and that'll take care of it. It's not going to. It will mask a little bit of it, but all you're doing is adding fuel at a time when it doesn't need it. The jets are going to add it at the lower RPM. They're going to help meter it through the entire power range, but initially, when the power valve isn't open, the main metering circuit is being fueled by the jet, and if you add the fuel there, you're not going to get it at the point you need it. So this is where the AFR will tell you that. So we're going to do a little bit of a driving test here to figure out where that power valve needs to open to get rid of that hesitation, to get rid of the stumble, to get rid of that situation where you're not getting near enough fuel. So the driving test is simple, but you're going to need the vacuum gauge in the vehicle with you and the AFR. So if you've got a standalone gauge like this, is fine. You can run enough vacuum hose as long as it doesn't get pinched off to your carburetor, as long as that's not your primary side or the distributor isn't seeing that or using it. Certainly having a distributor that's controlled by a spark box, an ignition box, whatever, is a little bit better in this situation. But you can pull manifold vacuum from a couple of different places. Manifold vacuum, gauge in the vehicle, engine completely warmed up, just go drive it around. What you're looking for is steady, sustained speeds, because you're going to look to see where the vacuum is at that point. So let's say 30 miles per hour, where you can get a nice, good, long, consistent run, not moving the throttle around at all, just 30 miles an hour and hold it there. Take the reading on the vacuum gauge, or better yet, have a passenger do this for you. 30 miles per hour. Then take the same type of reading at 40 miles per hour. Steady driving, 40 miles per hour. Where's your vacuum? It's going to drop as the speed increases because the load on the engine is increasing. 50, 60 miles per hour. You don't really need to go too much more than that. Those 4 data points are going to be just fine. So at each one of those mile per hour, record what the engine is seeing for vacuum, and then what you do at that point is now it gives you a place to start tuning from. Because in this instance, when we use the 4.5 power valve, maybe it wasn't opening at the time that we needed it, and maybe it needs to be opening a little bit quicker. And maybe switching to a 6.5 power valve will allow the power to come in a little bit more as it's needed, or more aggressively. Again, the AFR reading is super critical here. So vacuum and AFR reading at every one of those mile per hours will help you understand where everything's coming in, and now you're going to know that if the power valve is rated at 6.5 or 4.5 in the case that we put in, then you will see it on the vacuum gauge, and at what mile per hour does it hit that. If you need a little bit more fuel quicker for driving around town, a little bit more stoplight to stoplight, sometimes it takes a little bit longer for that vacuum to react, power valve to open, and you want the system to enrich the fuel a little bit quicker. So maybe that's the case, is now you see, well, you know what, maybe that stumble is occurring at that 40 miles per hour. I've still got 6.5, 7 pounds of vacuum in there. If I go to the 6.5, it's going to open when it hits that rating and give me the fuel that I need to eliminate that stumble at that mile per hour. That's why that AFR is so critical, because it's going to tell you where that situation is, and if you're a little bit lean, then giving it a little bit more fuel, depending on where that lean condition occurs, that's where you're going to be able to make that judgment, because now you've got the vacuum reading, you know what the power valve setting is, and you've got the AFR, so you know exactly where you're going to be at, and to make that decision on where to change that power valve sizing to. So that process there, when you set the initial and then go do the driving test, will get you into the ballpark and in the range you need, so that power valve will operate how it needs to give you the fuel that the engine is asking for at the right time. So super critical adjustment here. Again, a lot of folks will make the mistake of trying to clear out a little bit of a hesitation and automatically go into jet size. And I don't disagree that the jet is certainly a critical calculation, but take them in both in stride, and keeping that data and understanding what your AFR is, and understanding where the engine vacuum is, where you're experiencing that hesitation, and does that match up with the power valve? Am I enriching the system at that time to give it the right amount of fuel based on where the vacuum is? So all super critical things. Keep a little logbook in your car as you're working on it, and that way you can go back and reference it, and you'll know what adjustments you've made in the past, and what worked and what hasn't, based on changes in situation. If you're a cruiser or a driver normally, and you want to go to the drag strip and make fuel the carburetor differently there, you can. So I hope that gave you a little bit better understanding of the power valve and how it's used within that circuit and what it does and how you can help tune it a little bit to get the most out of it so your engine is getting enriched at the time that it needs it. And it's all based really on every application is going to be a little bit differently. Size of the vehicle, horsepower rating on the engine, what its modifications are, transmission, your driving style. All those things are going to make a big factor in it. So it's hard to say that one power valve size is going to fit all. It just depends on tuning. You're going to have to go out and tune it on your own to get it right. Now we'll be playing with this 650 on the GMC truck here over the summertime, and that's what we're going to do a lot of the tuning on, and we will certainly go through the power valve tuning process on that, and we'll show you that and how to make the jet sizes to get it all right. But certainly the vacuum gauge is going to be a big part of that process. Having an AFR gauge to read what's happening with the exhaust is going to be a huge part of that, and again, you can't do those without either one of them. You don't know when that's happening. If you try to do it without a vacuum gauge and AFR, everything you do is going to be a guess. So get the right tools, get the right sizes, try to figure out where you're at, get it at the initial starting point, and then keep tuning. It's what a carburetor is designed to do, is to be adjusted to where it needs to be so the engine will run. And you're given a lot of tools or a lot of places within that carburetor to do so, and it's very, very common, like I say, to make the mistake of just trying to change jet sizes to do that. So anyway, I hope that made a little bit of sense. I hope that gave you a little bit better understanding of power valves. If you have any questions on this one, don't hesitate to leave them down below. I'll be happy to answer them for you, and I guess we'll catch you on the next one. We'll see you.